For the application of statics in statics problems, we'll be using basically every tool in your toolbox that you've learned up to this point. So, problem-solving strategies. The first is it a system where you can apply statics? Is the system in static equilibrium? If the system is accelerating, then no, it's not a statics problem. If the system is rotating and changing its rotational speed, then no, it's not a statics problem. So specifically static equilibrium, it shouldn't even be moving. It shouldn't be rotating or have a velocity. So static equilibrium, acceleration and velocity is 0. Angular acceleration, which we'll talk about more in next chapter, and the angular speed is 0. So it's not rotating. The second is the most important step. Draw a free body diagram and label carefully the forces that are involved. Where are the forces being applied from? Right? So what direction are the forces, what magnitudes are the forces, and where are they being applied? In the earlier video with the merry-go-round, you could see that for the exact same forces, you got different results depending upon where they were applied on the outside of the merry-go-round. Some forces caused rotation, others did not. So their point of application is very important. Now, then you'll need to solve the problem by employing the conditions and applying the conditions of equilibrium. Now remember, force is a vector, so the forces in all dimensions must be 0 for this to be a static equilibrium problem. So all the forces in the x direction have to balance. All the forces in the y direction have to balance. And z direction, but usually we won't be giving you three-dimensional problems. All the forces in the z dimension have to balance. And then finally, all the torques have to balance. So the net torque is 0. Now, torques are caused by the forces you identified in the free body diagram. However, to get a torque, you need to know how far away that force is from the axis of rotation and what the angle the force makes with that radial distance. Well, some problems will have a clear axis of rotation, like the merry-go-round problem. The merry-go-round rotates about that central point. Or a door rotates on its hinge. A diving board, you might treat the end of the diving board as the point of rotation as the diving board moves up and down. Others aren't going to have an obvious point of rotation. For example, you could have a system where you have a board of some weight hanging off the edge of a cliff, and you might be asked, how far can a person walk out before that board tips over? There's no clear point of rotation here, but we can cheat. Torques have to be 0 regardless of the rotation axis you look at it. So you can actually pick a rotation axis that allows you to get rid of one of your unknown forces, which is kind of neat. What I mean by that is sometimes you might have more unknown forces than you can solve for, but if you're clever in where you pick your rotation axis, you can actually eliminate one of those unknown forces. So look at the example problems shown, or example, not the homework problems, but the example problems I do from the book for an example of this. And then finally, once you set up all these problems and solve for your unknowns, check the solution to see if it's reasonable. Again, you should do that with every single solution. Some you won't have an intuitive grasp about, well, does this make sense? I don't know, for this example here, right, how far can this person walk out? If you get that person can't walk out at all, it has to stay completely on the other side, chances are you might have done it wrong. Or that you get that the entire board just tips right over without the person on it in the first place, you might have done it wrong. Look to see carefully if your answer makes sense. If it doesn't, post on the boards. Right? If you're having trouble setting any of these up, post on the discussion boards. The discussion boards are not for you to use to solve homework problems without doing work yourself, but the discussion boards are there for clarification from other students and from me about what steps you might have done wrong or what your next step might be to solve these problems.